Now let's answer the final question of how many distinct permutations are there for arranging items in a circle. Okay, things change up just a little bit for this scenario. If you remember the trick, it should be pretty easily. It's very similar to arranging things in a straight line, but there's one slight change. So to demonstrate that change, I got this question here. 3 random people are playing hacky sack. I got this guy right here. I got a hippie right there. I got a stormtrooper playing hacky sack right there. How many different ways can you arrange them in a circle? And then, I should have a question mark right there, shouldn't I? If there were n people playing, how many ways could you arrange n people? Okay, so let's start with 3 right now. We could just try to figure these 3 out. How many different ways could I arrange them? Well, there's only one way, or actually there's only 2 ways. We got this setup right here, that's one way to arrange them. And then there's this setup right here. That's another way to arrange them. There's no other way. So there's 2 here. Now, some of you might be saying, well, what about I put him there, and then I put him there and him there. This is actually the same thing as this right here. Because really, it's relative to who's to your right and who's to your left, and nothing's changed in that scenario of who's to your right or to your left or right across. Because what you just did is you just rotated the circle. That's all you did. Oh, Control-C. What did I just do there? What happened to my circle? Oh, it's way down here. You just rotate it. You rotated your circle. So that doesn't change the arrangement in this scenario. So what I like to do for this situation is go back to my buckets, and what I do is I start with how many spots are there in the circle. Okay, in this situation there are 3 spots in the circle, and how many options do I have for my first spot? Well, I have 3 options for my first spot, 2 for my second spot, and 1 for my last spot. And then I got to divide out how many different rotations there are in this. How many different rotations there are? Because those are like duplicates in this scenario. So here, what you're seeing here is 1 rotation, okay? And then if I were to move him down here, the hippie up here, the stormtrooper right there, that is another rotation. And then if I move the hippie back down here, stormtrooper up there, and this dude right over here, that is a 3rd rotation. So there are 3 rotations, and we need to only represent 1 of those rotations. So what we're going to do is we are going to divide this, what I have over here, by the number of spots. So divide by 3. Okay? And so when we divide that by 3, what are we left with? Well, the 3 cancels out that 3, so we have 2 times 1, and that is just equal to 2. Right there. So that's my box method or my bucket method for answering this. Their formula they have for this, for circular permutations, is P sub n is equal to n minus 1, n representing how many spots there are, factorial. Well, what was our n in this situation? We had 3 was our n in this situation. N is equal to 3 minus 1 factorial. Well, 3 minus 1 is just 2. So we had 2 factorial, which is just equal to 2 in this scenario. So there's 2 ways to go about going on this. You could just say it's 1 less factorial than the number of people in the circle or the number of objects in the circle. And so in this situation, it would be 3 factorial minus 1, or sorry, 3 minus 1, which is 3. If you had 10 people in the circle playing hacky sack, if you had 10, then it would be 10 minus 1 factorial, which is just 9 factorial. If you had 20 people in a circle, it would be 20 minus 1 factorial, which is just 19 factorial. So that's how you figure out circular permutation.